Hi, I'd like to talk to you about the issue that plagues some of these Volvo S60 and V70Rs. And that issue is cracked blocks. It seems to be perhaps a common occurrence. I don't know if those are overstated or understated in the forums, but it definitely seems to happen that these 2.5 liter R model cars will crack their blocks. Let's talk about what happens, why it happens, potential ways you can mitigate that from happening, and then finally what you can do once it happens. So why would a car crack a block? Well, if you look at a picture of the inside of one of these motors, specifically the cylinders, you will easily notice they have a very thin little gap cut in between them as a cooling jacket. This leaves very little material on the cylinder wall. It seems like with enough detonation, this can cause this very thin sliver of metal between the cylinder and the cooling jacket to break open, allowing coolant to enter the cylinder, or typically what happens actually is combustion gases get into the coolant, overpressurize the coolant, make the car overheat. What is detonation? Detonation is when the car's explosion, so four-stroke motors, suck, squeeze, bang, out. Well, we're talking about bang part here. Is it explodes too soon. How does that happen? The cylinder intake air temperatures get too high, and no longer does the spark control the explosion, but it auto-combusts because of high intake temperatures or low octane fuel. The higher fuel's octane, the slower it'll combust, later it'll combust. So think about it this way: if you have like 100 octane fuel, you can have way higher intake air temperatures before it'll ignite than, let's say, 87, which will ignite at a much lower temperature. These cars have certain elements that allow this to be a problem, not only the cylinder design inside the block, but also the flip side, the hot air. These do come with dual intercoolers, and they are a parallel design. They're very over-designed and not very efficient. Why is that? It's because they're in parallel, and you have the typical radiator-sized intercooler that these Volvos run, and then on top of that, they added two little 1-inch ports that go to a tiny little front mount in front of the whole stack, which is supposed to provide additional cooling. This increases static pressure and makes maybe some air circulation not as efficient as it can be. What will happen is the car will heat soak because the hot air leaving the turbo will go into the intercooler, not get cooled down enough, and enter the cylinder chamber, where it'll be extremely hot, 150 plus degrees Fahrenheit. You can really get into some problems. What you can do to mitigate this, of course, is to run a better intercooler. Several options are available. There is the DOE 88 drop-in intercooler, which sits just in the same place as the factory system. It's just a little bit thicker and has way better airflow qualities. There are front mount intercoolers from Snab, and I believe Fuzz sells one, and a couple different options, as well as just going completely custom. All these are available to help with this detonation issue. What you could also be careful of is how you drive the car. If you're beating on the car very aggressively in very high ambient temperatures, the likelihood of detonation is much more than if it's a very cold winter morning. Also, fuel quality and fuel system component health. If you have a dead, weak fuel pump, if you have a clogged fuel filter, you're not going to get as much fuel, which typically more fuel cools cylinder chambers down a little bit more. So that could also lead to detonation and other issues. When detonation occurs in a cylinder, it can cause all sorts of damage, including actually breaking the cylinder liner into that cooling jacket. Now that we've discussed some of the potential reasons why it happens, and some of the solutions in terms of bolt-on parts, let's dive into the motor. What you can do, what I have done, is I've chosen to remove the cylinder head and do something called shimming the block. Shimming the block involves taking a piece of metal and sticking it inside that little relief gap that exists, so that as the cylinder pressures, let's say this is cylinder 4, this is cylinder 5, they're pushing, they no longer have an empty void where they can break into. They actually have now a solid connection. As you can see here, I've actually taken a flashlight to show the relief that is cut in between the cylinders. This is meant to act like a cooling jacket. So to fix this, I've actually invited over one of the members of the Sweet Speed forum to help me shim my block. So come take a look.
So what we're going to do is, I've already looked at them with the 25. So we're going to go one by one now with the 28. They should all end up with a 35 thousandths gap. That is tight. These are amazingly clean and consistent.
Yeah, I was noticing they were fairly clean, but I know that between cylinder 4 and 5, after 20 thousandths, I was having a hard time getting it actually to the middle. Like 32 would kind of start on either side, 30, but right in the middle, it was going to take some force, so I was a little bit worried about that one. So yeah, show me.
I just ran a 30 through them with no issue.
All right.
So here's the 32.
Yeah, that's the one I was struggling with.
32 is a little stiff. That's okay. 3 and 4 is a little stiff, which is okay. They're all about the same, Julian.
I think the motor had a pretty easy life in this car from everything I've seen.
It definitely did.
The head, I mean, if you look at the bowls on the head, or the areas around the valves, it's so nice and clean. There's no cracking, no nothing. Versus the other head I had that just was in awful shape. So that's your trick, just hammer them in, huh?
Yeah. So this is a 32. This isn't a 35.
So I was wondering why people say like, oh, just measure them and just apply whichever one versus what you're doing here, which is kind of.
No, I mean, as an engineer, you know that auto manufacturer like Volvo isn't going to say, it's okay to have 5 plus or minus 2.5 thousandths on, on a machined water passage. They're going to be consistent. Maybe plus or minus 1. But in my experience, 35 thousandths is what they all take.
Just love the quote-unquote cheap insurance this will provide me as the build continues.
Absolutely.
Because before this, it's just you're flying blind, and with a good tune, like you said, it's reasonable. But anything past stage 1, I think that if you're really going to take the car out and drive it hard, this is kind of a must-have.
That really is the key, though, is a good tune. In this environment where we've got 91 octane fuel, relatively high ambient air temperatures, a good tune is really key.
And that's what also kind of worried me is, what's not to say that one day I picked up 91 that was actually a little bit off, and I go drive the car hard and it just starts detonating on me. Which is why one of the first mods I always do to these is stick a big intercooler on them. I don't know if you saw, it's got the DOE 88 drop in.
Right.
Second time I've done that.
Keep your air intake temperatures low. You'll see if, depending on what level tune you do, especially with Gustav, you'll see in all the logs, you'll see the correlation between intake air temp and knock retard. And you just see it in the data.
So that was a 30 that you went through? No, 30?
That was a 32.
So, oh, wow, one more to go.
Yeah, so they're all consistent at 32. And so now we'll pull all the 35s out, clean the water passages, use your Permatex sleeve seal, And we'll tap them in with my high-tech aluminum block.
So basically, you're just going to make them like into an S shape or a C shape to kind of clear the...
Exactly. So we'll start with one, make a template.
Alrighty, got them all chopped up and ready to fit.
Yep. So got four shims that are essentially all exactly the same. Close enough for what we're trying to accomplish.
Very happy you told me that like they could be expanded back. The feedback I heard was measure them and use whatever you have. The second one was they're always 30 thousandths of an inch. But not knowing the future of this motor in terms of power output and abuse, I'd rather have it ready, set to go for any future it may have.
Okay. So we'll give it a little tap to get it started. A little bit of an awkward spot here.
It's good that you have that aluminum block so it doesn't mar any part of the head.
Right. Yeah. I really like the block. Just set my other rag down over here.
We've got paper towels and more shop rags if you need them.
Okay. One down. Nice thing about the aluminum block is it's really a nice go no go. You can't push it any deeper, and at the same time that it's flush. Is really nice on this. It's amazing to me that this engine has 180,000 miles because these gaps are all very consistent. a little aggressive with this one.
And that paste will just basically start hardening, I guess, with temperature and ensure those never move and shift or anything like that.
Yep, it's the stuff is room temp cure. Extremely high film strength, and final film thickness of around 1/10 of 1,000th. So we'll close any gap up a little bit more, but you see that last one. So 3.4 and 4.5 are typically the cylinders that collapse. You know, they're furthest from the cool water coming in. So you have highest heat concentration, and these were essentially 35 thousandths.
Awesome.
Tighter. Looks
Cool.
good.
Well, this is how you shim your block.
Here you can see the finished results of the shimmed block with the feeler gauges. A huge thank you to Austin V70r from the forums for driving up and helping me accomplish this today.
Those are some preventative measures you can do if your car, hasn't broken yet. What do you do if it breaks? Well, first let's talk about symptoms. It may overheat, it may not. It usually will use some coolant, but typically the coolant will only end up in the cylinders after a long run of the car and letting it cool off, not while you drive. Because while you drive, there's a lot of pressure pushing outwards into the cooling system, which means you'll have combustion gases ending up in the cooling system. This can be tested with a block tester, which is a tool that you put on top of the coolant expansion tank with the cap off, and you suck the air coming out of the cooling expansion tank through a special fluid in a crystal, and if there are presence of hydrocarbons in that vapor coming out of that expansion tank, then the fluid will change colors. That I've had reasonable luck with, not always. The biggest telltale I've noticed is a stumble on cold start. And also when you drive the car hard, all of a sudden it'll dump all its coolant back out because the pressure inside the system is becoming too excessive for the cooling system to handle, and there's usually a safety mechanism built in the cap of the radiator where it'll just allow it to just dump the coolant out, or you might just blow a radiator hose. So all these are things you can have to watch out for. If you see one of these cars for sale with a bad head gasket, I would avoid it because you're looking typically at a block. What can you do though if you do end up buying a car like that, or your personal car, cracked the cylinder liner? Well, there's several options out there. The most expensive and fanciest way to fix this would be to get Darton cylinder sleeves, which you actually end up doing, and it's a really cool video. They machine the inside of the engine block out to fit new cylinder sleeves, which are much tougher, and they interlock and provide, nuclear bomb-proof levels of resistance against this issue. This is usually fairly expensive because you got to take your block out completely down bare, and then you got to bring it to the machine shop, buy the sleeves. I'm thinking $5,000 to $7,000 if you do some of the work yourself, and those are just ballpark numbers. The other solution, which I think a lot of other people that are more the DIYers will end up doing, is you pick up either a 2.3 or 2.4 block, typically from like a pick and pull or a junkyard. These motors can be found in earlier versions of Volvos, as well as a T5, late model T5 of the P2 generation. And what ends up happening is, since they have smaller displacement, they're 2.3 or 2.4 versus the 2.5, there is more meat around that cylinder, that piston, and which mitigates the issue of them cracking. However, that said, you should still swap in a better set of rods, maybe some aftermarket eBay rods, the forged or Chinesium rods. People seem to have fairly good luck with it. I believe your crank gets swapped in. So it's still not an insignificant amount of work. because you're looking at bearings, piston rings, and some people might reuse a piston rings that came from a junkyard motor. At the very minimum, I would throw a set of rods at it because these cars do have upgraded rods from the factory over the other cars. But cost is gonna be way, way lower. Maybe $2,000, you know, think about a couple $100 for the block, a couple $100 for the head gasket set, a couple $100 in machining, a couple $100 for the rods. So those are all issues that, you know, you can kind of decide. What I have noticed though, and a word of warning, is that I purchased a head for my car off a car that had cracked its block due to detonation. And both the seller and I were like, well, you know, just the block went bad, so the head must be good. So I got the head and I took it all apart. And as I was removing one of the spark plugs, all the threads came with that one spark plug. And I was just kind of confused what happened, why. Did somebody cross-thread it? Did maybe the head sit outside? Did it just get some gunk in there? So I kind of reached out to some of the Volvo community and asked them, like, any issues? And one of the experienced Volvo guys from the P2 forums, like, don't run that head. I can guarantee you it's cracked. So lo and behold, I took a closer look at the area around the spark plug, and he was right. There were like 4 cracks right there on more than one cylinder. So again, if you do crack a block, there's some chances that you've also hurt your head. Preventative is just the best solution. Something I didn't talk about, which is more on the software than hardware side, a good tune definitely helps. You know, if a tuner programs a stage 1 into this car, which means no additional hardware needed, there's already a much reduced risk of the car detonating because by the way they adjust the air fuels and the timing of the car, they can mitigate detonation. At a very minimum, personally speaking, I do intercooler and tune, and that I think is pretty much good for anything but like heavy duty track work. So whichever option you took, I just wanted to kind of, you know, do like an information dump of like, this is everything I know and I've researched about this problem on these cars. It does plague these cars. It's like a head gasket on a Subaru or like an expansion tank on a BMW. It's like, oh my God, is my car gonna blow up? And maybe, you know, right? But if you think about it rationally and you do the right decisions, you can, you know, mitigate it before it happens. And you can, you know, eventually engineer it to where it will never happen. Anyways, thanks for watching.